So good morning and thank you for joining us on our NETGEAR Insider webinar. Today we're going to be talking about ProAV and its marrying with the world of IP. So I'm your host, I'm Kieran Purdy, I'm a systems engineer for NETGEAR UK, and I'm also joined by Rob Muddiman, the EMEA sales director of ZeeVee. So we will look like this today. So this is going to be the agenda. We'll roll through some intros quickly. We'll take a look at AV, not just today and not in the future, but also in the past. We'll have a look at the SDVoE, and if you don't know what it is, we'll introduce you to that. Some of the product solutions, some needs and speeds, and then we'll spare some time for Q&A. So, like I said, my name's Kieran. I look after business products at NETGEAR. I cover the UK and Nordics, and I'm a systems engineer, so all kinds of techie solution scoping, specing, and training. And we're also joined by Rob, and Rob looks after EMEA for ZeeVee, and he is the sales director. So I'm going to hand off to Rob, and Rob is going to take us through a journey on AV over IP, some of the past, some of the future, and some of the present. So Rob, over to you.
Okay, yeah, thank you very much, Kieran. So I think this is a really exciting time for AV, and it also is a time of opportunity for resellers who are currently playing in the IT world, because the AV marketplace, actually distribution marketplace worldwide. I think a Gartner number was coming out with something that is worth $8 billion worldwide, and this is a market that probably today is untapped by the IT world, and it brings huge advantages. So that's what we're going to be covering. But a bit about ZeeVee. We're 12 years old now. We're in our 12th year. We're a US company based just outside Boston in the US. So we design and we manufacture a product over there. Our prime focus is video encoding and creating the ability to send video over IP networks. This is our focus 100%. So we're not one of these companies which has a massive breadth of products and maybe a shallow depth of knowledge. We're a company which has a narrow range of products, but a huge depth of knowledge within that. Next slide, please, Kieran. Okay, so as I already mentioned, AV over IP, it's it's the next step, really. It's the next logical step. Up until now, most other kind of technologies have moved to IP. So audio has been over IP for quite some time. And really, when we're talking about AV over IP, it can mean many things to different people. But in the context of this presentation, we're really talking about AV over IP within a facility, within a building or a campus. And we're not talking necessarily about streaming over the internet, although that is another form of AV over IP, of course. But the market that we're talking about and we want to address is the AV over IP, which is replacing the traditional AV matrix way of doing things. And we'll come on to that on the next slide. Please, Kieran. So traditionally, AV has been deployed in corporates, in retail, in education, all of those verticals, using what's known as AV matrix switches. So AV matrix switches, they're basically proprietary. So there are many manufacturers in this place. There's probably 3 very big manufacturers that dominate, and none of their product is compatible with each other. So absolutely proprietary to each manufacturer, not standard based at all. And this is what it looks like. So you've got a switch in the middle, you've got transmitters, you've got receivers. So the switch in the middle, it's a frame, and within that frame, the manufacturer will have I/O cards that plug in there. The I/O cards will have possibly inputs to take Cat5, Cat6, fiber, or they may have direct inputs, meaning HDMI, VGA, etc. But it's proprietary and not particularly scalable. So those switches the frame sizes are fixed, typically to a fixed number of inputs and outputs. and they're typically square. So the number of inputs always equals the number of outputs. So this is how it's been done. And if you wanted to do things like, sexy things like video walls, you needed a separate processor box to go on the output. If you wanted to do something like multi-view, by multi-view I mean having one single screen and many, many images on that screen, you're also going to need a separate multi-view processor. With this arrangement here, it's very inflexible, but it does give you the ability to switch sources through to displays using transmitters, the switch, and the receivers. Next slide, please, Kieran. So, as I said, they're very, very limited, these proprietary switches. They're all, let's just recap, they've got fixed sizes. So it's either going to be an 8x8, so 8 inputs and 8 outputs, 16x16, 32x32. So they're lacking scalability and flexibility. And what we're finding is now that end users, whether it's education, universities, retail, corporates, who've got these installed, if they want to add additional devices, displays or sources, they can't do it. Not without changing the frame and moving up to the next size up, which is all cost for them. It's all inconvenience. Furthermore, as an integrator or reseller supplying this equipment, there's an awful lot of custom programming for those switches. And what gets worse, because every manufacturer has their own proprietary standard, it means the integrator has to learn the programming of maybe 4 or 5 different manufacturers. So nothing is standard. That makes it, it means these products are expensive to purchase, install, and support. And, as I said, they're proprietary components. You cannot combine and mix components from one manufacturer to another. So all in all, not looking particularly good for the future. And it's definitely been a burden on the AV industry and end users in the past. That can all change. Next slide, please. So it's going to go, matrix switches. Okay, we're laboring the point here. They don't meet the needs of today's AV demands. There's no standards. They're not flexible. They're not particularly scalable. They cost expensive. And what's worse for the end user, if they go with one manufacturer, they're pretty much locked in. So what's a better way to do this then? Next slide, please, Kieran. It's AV over IP. And, to send video over IP, you need to do something to it. So typically you need to encode the video, which is what ZeeVee specializes in. And over the last 10, 15 years, video over IP isn't exactly a new phenomenon. It's been around for quite some time. What has changed is the encoding techniques and the efficiency of doing this. So if we went back 10, 12 years ago, we had something called MPEG-1, a very crude type of compression and encoding to send video over IP networks. And that's moved all the way up. So today, MPEG, H.264 and JPEG is common encoding method. But actually what we have today is something which is the ultimate that we've reached. And that's the ability to send video uncompressed over a network. And that's what SDVoE is all about that Kieran mentioned earlier. So you can send video 4K up to 4K uncompressed over a NETGEAR 10 gig switch or any other 10 gig network for that matter. So encoding has improved dramatically over the last few years. Network speeds, if you look at the second line down, have increased exponentially. So now I would argue that any new network that's been installed anywhere, more likely it's going to be a 10 gig network that's going to be installed in a facility rather than a 1 gig. We always need more bandwidth, and looking to the future and future-proofing, I would suggest quite strongly that 10 gig is the way that people are going. I think there's a lot of evidence to back that up as well that Kieran could probably share. The other great thing is, of course, bandwidth has come down. The cost of bandwidth has decreased dramatically over the last 10 or so years. If you looked at a non-enterprise 24-port switch back in 2010, we'd be looking at a list price of something like $10,000 for those 24 ports. Whereas today, a NETGEAR 24-port copper switch is listing at around about $1,800 now as a list price. So dropping down dramatically. But let's take a look at what's happened in the AV world on the bottom slides there. You can see that with the proprietary matrix switches from two of the big players within the AV world, so that's Extron and Crestron, actually nothing changed at all in the cost of their frames. So that $9,000, $10,000 odd dollars that you can see there for the Extron frame there is just for the frame. By the time I've added in all of those I/O cards that I mentioned earlier on the earlier slide, we're probably talking about a list price of $20,000 to $30,000. Same goes for the Crestron solution there. So compare that against the $1,800 for the NETGEAR 24-port switch. It's quite significant. Next slide, please, Kieran. So if we take all of that into consideration, there's a much better way of moving AV around a facility, and that's AV over IP. So now, instead of having a proprietary switch in the middle, we've got a standard architecture in the middle, and that's an IP switch or a network, so such as a NETGEAR switch. So along with a switch, now you have encoders on the input side rather than transmitters. So the encoders connected up to the video sources, whatever those video sources might be, cameras, PCs, media players, whatever. And then on the other end, we've got the decoders which connect up to the screens. So now we can switch any video source to any screen. Actually, we can also do things like multi-view. So remember I mentioned multi-view, so having one screen where you've got multiple images on there, you can do that. And you can see we've just got one decoder that will manage that for you. And we can do things like video wall. So now we've got a video wall there being shown, which is a 2x2, but really there's no limit to the size of the video wall. 5x5 is one of the more ambitious ones. And you get huge flexibility with that. So not just switching video, but we can switch video, we can switch audio, we can switch all of the other signals like USB control. So if you had a touch screen in your facility and you wanted to control your PowerPoint presentation from the touch screen while you're presenting, you can certainly do that with this type of solution. So in ZeeVee's case, in order to make the installation practically plug and play, there's another component to all of this, and that's this box called Management. That's a management platform which sits on the network anywhere. And that basically monitors and auto-finds encoders and decoders as they plug in. It works out whether there's a source connected, what the resolution of the source is, what the display connected is, and what the capability of the display is. And all sorts of clever stuff can happen here thanks to the management platform and the ZeeVee encoders and decoders, including auto scaling and what have you. So, you know, that's a flavor of, and you can see it's much simpler now. That's a flavor.
Rob, I just wanted to,
yeah.
also, I just wanted to add on that from my perspective in a networking world, that one of the obvious things I can see here is the fact that now we're switching over to things like copper and fiber cable.
Yeah,
we're having the ability to separate where our source and endpoints are for the video, right? So if I think about copper, I have 100 meters that I can run in between the source and the decoder. And if I'm looking at fiber, certainly from a NETGEAR perspective, we can look at as much as 10 kilometers down a stretch of fiber. How does that compare with a proprietary system?
Well, the copper-based proprietary systems are based around a technology called HDBaseT, which allows video to be sent over category cable. However, it's proprietary and it uses a chipset from Valens, which does its best to compensate for all of this high bandwidth stuff going down the cables. But ultimately, it's if you talk to any AV integrator who's installed HD-based T, they will tell you all of the challenges that you have, including routing of cable, using the correct type of cable, not running their mains cables, etc., etc. So, you know, it's a real challenge to get 100 meters with that technology. There are fiber switches available for proprietary stuff, but again, it's proprietary and they're hugely expensive. So there's no match really from the proprietary side of things to the flexibility that you get with an IP switch, particularly like NETGEAR, when you got the new 4396 port switch, which is modular, and you can combine copper and fiber. There's just no match in terms of flexibility and scalability, and you're working on a standard platform. That's the key thing.
Yeah, for sure. Awesome.
Next slide, please. So just to recap, AV over IP, it's scalable. I mean, basically, you can support any size configuration. The largest install we have is on one single network is 850 endpoints, which is huge. You couldn't do that with a proprietary matrix switch. It's hugely cost effective because we're running on standard net architecture, which is IP. And actually, with the NETGEAR switches, and I'm not going to steal Kieran's thunder too much here, the beauty of it is with the NETGEAR switches, the 4300 is, there is no programming. It's just, they come pre-configured, in fact. So out of the box, you take those, you plug in the ZeeVee encoders and decoders, and you plug in the ZeeVee management platform, which automatically finds our encoders and decoders, and you're up and running within minutes. Really, it's not a day, 2 days spent programming for that. Next slide, please. So ultimately, we got to, we can't lose sight. What do AV users want? What do end users want? Well, they probably don't care too much how it's done, but they want cost-effective solutions for AV. They want a certain amount of future-proofing. They want a lot of flexibility. And above and beyond anything else, they're pretty fed up with investing in technology, which is proprietary and ends up being stranded investment. So that's all going to disappear if the route they go is AV over IP. So the argument I say is, even if today you go with ZeeVee and you go with NETGEAR or whatever for AV over IP, and if in a few years' time you suddenly decide, you know what, ZeeVee doesn't have what we need anymore, we want to move to someone else, you've not wasted anything. You've still got the IP infrastructure in place, which you can use to move video around. So, I would say the easiest way to achieve all of this, of course, is using NETGEAR pre-configured switch, ZeeVee solutions, which pretty much plug and play, as near as possible to plug and play anyway, to work together, and you're going to get an AV over IP deployment that's up and running in a very, very short amount of time, and be very flexible to support and maintain. Okay, next slide, Kieran. So I just need to mention this very, very briefly, because I know someone's going to ask it, so I want to get it out there. AV does use a lot of bandwidth. So if we look at the lines here, the bottom line there is 1080p, so HD, which is what you'll kind of be seeing on most screens. It uses 3 gig of bandwidth. And then the next 2 lines up are 4K resolutions, which use 6 gig. And you can go beyond that as well, of course. HDR, which is if you go into any retail store now, HDR is the thing that is being pushed for high quality, really deep image resolutions. But you'll see that none of those actually resolutions on the bottom fit on a 1 gig network. So if you put them on a 1 gig network, you're going to have to compress. And there is technology to do that. ZeeVee has technology to do that. But actually, if you went the SDVoE route, which is what Kieran's going to talk about next, all of this fits on a 10 gig network, right? SDVoE is all about 10 gig networks. So it's going to work. Next slide, please, Kieran. Very, very briefly, if you're looking at bandwidths, because you might say, well, I've only got a 1 gig network, or I've only got the budget for a 1 gig network, you can still do AV over IP. It just means that you're going to have to compress the image, which means you're going to lose some image quality. How much you compress that image really depends on the application. If it was digital signage, it probably wouldn't matter too much. You could compress it a fair bit and still be fine. When you compress, there's also a thing called latency, which means there's a delay between the source and the display. In most applications like digital signage and whatever, where you're not in the same room, it's not important. If you were in a meeting room and you had something on a laptop and you're using a mouse and you're looking on the presentation screen, then latency does matter. So just something to bear in mind. Not really got enough time to go into that much detail here, but okay, Kieran, I think that someone's got a question, or yeah.
Yeah, it's a good question, Justin. I'll be covering that in a few moments.
Okay, so maybe jump ahead then, Kieran. So this is the thing to bear in mind. The future is now. The AV world is changing. For AV and IT integrators, there's huge opportunities out there. And some of it is education to make the end users aware of this and spot the opportunities. And in some cases, actually, it's being driven by the end users who are becoming educated, and they're going to resellers and integrators and saying, this is the way we want to do it. But anyway, it's a whole new world and very exciting opportunities. Last slide, really. Get asked where would you use this technology? Well, if you look at the verticals there, basically every vertical: corporate, retail, hospitality, stadiums, education, healthcare, government. Across the board, really, anywhere where you would have used a proprietary matrix switch in the past. So even NASA, you've seen all the stuff with Mars at the moment. So within that control room, that's where SDVoE, ZeeVee, SDVoE, and NETGEAR equipment is being used to view video on the screens there of the shuttle going down to the Mars surface. Stadiums, retail, etc., etc. So you get the picture. It's everywhere. Okay, Kieran.
Awesome. Well, thank you, Rob. That was certainly some really good insight there into kind of where AV was, where it is, and where it's going. I think much like a lot of stuff that seems to transition over to IP, certainly we saw it with telephones, where we're kind of seeing it, and it's happened with things like IP, CCTV switching over, and we're seeing a lot, maybe less things like coax and traditional runs and switching over to IP. And certainly it kind of looks like AV is the next logical thing that will switch over to IP. So thank you for that. Now, Rob mentioned, and I mentioned a lot within that around the SDVoE. Now, if you don't know, the SDVoE is the Software Defined Video over Ethernet Alliance. This is a non-profit consortium. It comprises of a whole host of different manufacturers. You've got guys like ZeeVee who make encoders and decoders, and you've got guys like NETGEAR who make networking manufacturing. The idea is that we're all coming together, doing our bit and standardizing how we do our bit so that we can all interoperate with each other. And like Rob said, necessarily maybe you've got a piece of ZeeVee kit now or a piece of NETGEAR kit today, tomorrow, maybe your requirements change, but there should never be a waste of equipment, because the idea is we should all be able to interoperate with each other. Now, they do have a website. It's called SDVoE.org, and they have a lot of great resource on there. They even have online free learning where you can get certified up as an SDVoE certified engineer. So I definitely encourage you to go over and take a look and take advantage of the resource that the SDVoE are putting out there. Now, at the moment, there's around 40 members, and it is growing. I remember last time we did a webinar on AV. Initially, it was, I believe, 20-something members, so it is growing fast. In the middle, you can see the founding members. So you've got us, you've got ZeeVee, you've got Crunchy, guys like Sony in there. You've also got the contributors, guys like Ordinate. And then again, there's the adopters, and this will only ever grow. Now, the way we work within that is to ensure that our products will all conform to providing flawless delivery of 4K 60 frames a second over IP with zero touch configuration. Now, I know we had a question from Justin on our thing, and Justin asked, how does a pre-configured switch deal with multicast configuration such as IGMP snooping? Now, what we do at NETGEAR as part of being part of the SDVoE is to agree to pre-configure our switches with IGMP snooping for that exact reason. Now, just to cover off, we won't go too technical, but I do just want to talk to those that maybe don't know. Now, the way we send video when we're doing it over AP is over multicast. Now, within the world of IP, we kind of have three different types of communication. We have unicast, which could be me talking to Rob point to point. We have broadcast, which would be maybe me shouting in a room, and everybody in that room is going to hear what I'm saying. And then we also have multicast. Now, multicast is similar to broadcast in the concept I shout, but with multicast, we can configure it so that only the people that want to hear me will hear me. Now, with AV, we send video over multicast, and traditionally, if you do this on an IP switch without configuration, inadvertently, you will flood your network with your AV traffic. Now, we saw the bandwidth that Rob were talking about. We can get as high as 10 gigabit per second and even more. And when we're looking at the SDVoE stuff, it's all based around 10 gig. Now, you can imagine what the outcome would be if I was to flood my network with 10 gig traffic to every single device and port on my network. Yeah, you're going to take that network down pretty quickly. So what NETGEAR does is pre-configure all of our M4300 switches with IGMP snooping on VLAN 1, and we also have an inbuilt querier on VLAN 1 as well. So that now with pure plug and play and zero configuration or having to log onto the switch, what you can do is take your ZeeVee encoders and decoders, take your sources and your endpoints, plug it all in, and it will just work with zero configuration.
And that's really important. I would say from ZeeVee's point of view, Kieran, 90% of the support we end up giving is with switches which have not been configured correctly. That just doesn't happen with NETGEAR switches. It's just one of those things that's taken off the plate for you and just makes things that much easier.
Absolutely. Now, the switches we're talking about are the NETGEAR M4300 series. Now, on the right-hand side, you'll see every product within that series. Now, it's a mixture of both 10 gig, 1 gig, and now 40 gig. So there are a whole different host of switches in there. Now, all of these interoperate with each other to do what we call stacking. So all of these can create one virtual switch, which gives you things like resiliency, redundancy, and single IP address management, should you need to manage that product. And in total, you can be looking at a distributed setup, because remember, we have things like copper, fiber, so we can place those switches in different geographical locations and still stack those to create one virtual switch. So you're looking at a combined infrastructure of up to 384 1 gig ports. So potentially, if you're not looking at things like 4K and you are looking at lower bandwidths, you still have the ability to do that with these switches on 1 gig switches. And again, it remains the same. All of these switches are pre-configured. And in total, you can look at up to 768 10 gig ports, all in one virtual stack, which is a pretty insane number by any count. And then we got up to 192 40 gig ports. So again, scalable. And when you are looking at taking maybe multiple streams of 4K and moving those around per device, so if you were looking at an installation maybe across a stadium and you had different decoders and encoders, but you wanted the ability to switch from any place to any place at any time. Obviously, bandwidth between switches then becomes a consideration. So we have the ability with 40 gig to scale that bandwidth between switches, not just from 40 gig, but by combining ports at 40 gig and creating, things like 240 gig interconnections between switches to send multiple streams of 4K from any encoder to any decoder all at the same time. Now, one of the main products and the newest one within that range is what we call the 96X. And this is probably the most flexible product within the entire M4300 portfolio. And with this, and we're looking at our 96X configurator, which you can get to online. It's a public facing page and it's on netgear.com/96x-config. You come on, and the idea is you take an empty chassis, and really, because we're taking away the configuration piece, and we are all minimizing the configuration of the NETGEAR piece within the networking side, the idea is you're going to look and you're going to say, do you know what? I've got 10 encoders, 10 decoders. So I'm going to come along to here I'm going to put in how many ports I want. Is it a copper ZeeVee encoder and decoder? Yeah, okay. So now I'm going to look at 10 gig copper. I know I need X amount of them, so I'm going to pick 8 or I'm going to pick 16. And again, maybe I'm using 10 gig with PoE. So that's one of a new thing we're doing at NETGEAR. So even if you need the ability to provide PoE over a 10 gig port, again, you can do that. Am I looking at 10 gig fiber? Do I need 40 gig because I'm going to actually connect up a few different chassis and I'm going to send that data from potentially one place over to another place? We're including things like redundancy for our power supplies. Do I need a installation service? And I input all my requirements. That'll give me a bill of materials, then take away and purchase wherever I may purchase my equipment, be it via reseller or distribution or within the channel. And that should be your process for configuring how you go about that switch. Now it's all modular, this switch, so it's purchased in 8-port modules. So as I buy as I go, so it's flexible. Potentially if I only ever need maybe 8, 16, 24, 32 ports today, I can buy what I need today, but then tomorrow I'm not wasting my investment. I might have to come along and say, well, actually I had 24 ports, I bought a 24 port switch, but now I'm looking down the line and I need 48 ports. I'm never going to throw away that switch and start again. All I've got to do is then add on. Now the advantage to doing that, because you may say, well, maybe I'll just buy a 24 port switch now and I'll buy another 24 port switch. But don't forget, we always have to consider within IP our switch to switch connections. And if I had 12 ports of 4K and I had another 12 ports for the decoders, I have to remember that if I want to send that over another switch, I'm looking at potentially, anywhere up to 100+ gig that I need to then interconnect between those switches for the ability to send that. Now, if I house that all within one switch, all the switches that we sell in NETGEAR, and certainly within this range, are what we call line rate, which means if I was to plug in 48 encoders and 48 decoders into this 96 port switch, it will work. It can push the bandwidth that we put into it because it is a line rate switch. So it's going to have no issue running 48 sources and 48 encoders, decoders, all at the same time, all running 4K. And from a price perspective, and obviously we talk retail, this is going to come in massively cheaper in what you would look at from a proprietary system. And with this, and certainly in the UK and across the world, one of the main advantages is zero configuration, but also the support and the warranties that you'll get with this. Now, with this particular range of switches, all of them come with next business day warranty replacement. So if you are looking at a protection for your investment, we are providing it. It's free of charge. We also include 24/7 chatter support, which is online to our support team, free of charge. And then you can upgrade for a very minimal cost, actually based on the cost of the product itself, to 24/7 telephone support. And you receive that for 3 months for free, and then it flips over to our chat support and you can upgrade. Our PoE, got another question from Justin. Are PoE++ ports available? So PoE Plus is, if you're referring to 60-watt PoE, they're not at the moment, Justin. We are doing PoE and PoE Plus at the moment on the M4300 and on the 96X. So the kind of ProAV application behind this is the ability to do this. And I think Rob kind of summarized it really well in the fact that the verticals cross everything because video is everywhere, right? It could be the video wall that NETGEAR is installing in its office. It could be the advertising screens that my wife has at the university where she works in marketing. It could be the signage at a bus stop. It could be the screens at a stadium. It could be a concert. It could be a business in Green Park in Reading and anywhere in the world pushing adverts out. It could be meeting screens. It really does transition over everywhere. Now we understand very much, and I come from a networking background, and I've gone through a learning curve of learning AV. And like I said, do take advantage of the fact that SDVoE guys are giving out free training that you can sign up to and do online on their website. Also guys like Ordinate who are also doing free online training, and we ourselves have white papers written for Ordinate. So again, we can integrate with good stuff like that. But when we look at that, it really does just transition everywhere. And the ability to say, do you know what, we're not going to take an AV guy and try and turn you into a networking guy, because realistically it's going to take an awful long time, and it's a massive subject, and the same vice versa. There are resources out there. NETGEAR does a lot of work into putting really good online content on, into knowledge-based articles, into things like training guides or pre-written guides to help you follow. But as much as we can, we want this to be a plug and play application. We want the AV guy to come along and say, do you know what, I can take this really high powered, high performing product that in a networking world sits really high up the stack, and I can place it straight into my network, and I can plug in all my encoders, my decoders, and it will just work. And that is what we want to bring. We want to make it as simple as possible, so that, again, we don't want to put overhead on the guys in the AV world as much as they probably don't want to put overhead to us. We just want to merge the two and make it really simple for you to go along and deploy your signage, your cameras, your servers, your cinema screens, whatever it may be. And then the end goal kind of looks like this. And having the flexibility, like I touched on earlier, to say, do you know what, and from a networking perspective, you know, if I was to say I'm going to install switches all over the place and put them in ceiling tiles, not saying it doesn't happen, Rob, but it's a nightmare for us, and we like to put them in server rooms and data cabinets, and having the ability to run things over fiber and copper gives you the ability to say, do you know what, I'll have a screen hundreds of meters down the road, and I can still take that infrastructure and place it where I would traditionally place my IT infrastructure. And to me, certainly from a networking world, that's a really big advantage.
Kieran, we've got a question from Andrew, actually, who's asking how hierarchical are the switches, i.e. multi-switch AV networks. He's saying most of his diagrams look like a replacement for an HDMI, so a proprietary matrix. So maybe if I take the first part of
Sure.
Take the first part of that question. So you're right. For simplicity here, what we're showing is a network or a switch to do a comparison with a proprietary AV switch, just because that's where the way things were done in the past, and this is a like-for-like replacement. So it's like-for-like replacement. Even, you know, what we're finding is actually that maybe 60–70% of all installations of AV over IP at the moment are going in still as parallel networks, whether that's 1 gig or 10 gig. They're still going in as a parallel network. They're not on the customer's IT network necessarily. You know, there's no reason why this couldn't be on the customer's network at all. But I think because the way things have been done in the past is parallel, there's and to a certain extent the way AV over IP was the capabilities of AV over IP in the past wasn't so good, that, you know, network managers have been nervous about putting AV over IP. But with a properly configured network and switches, as Kieran pointed out, bandwidth is never an issue. It's going to work. It's going to be fine. Typically, you know, the AV might be put on a separate VLAN. That's typically what might happen. So yeah, this is with a single switch, but if you had multiple switches connected up, it would all be about the design of that network. So, you know, I'm not an IT guy, I'm not technical, maybe Kieran can answer this better than I can, but it's the bandwidth that's available between those switches, which you've got to take into consideration. So if you've only got 10 gig between a couple of switches, then the number of streams that you can send between those switches is going to be limited to that 10 gig. So in the case of 4K at 6 gig, it's going to be one stream. But if you've got uplinks or more bandwidth between the two, then you're going to be able to run more streams. Kieran, do you want to maybe expand on that? Because maybe I haven't done the best job of answering it.
No. I think we're spot on. Like you said, we have, for simplicity's sake, made this look like a replacement to a proprietary system. Certainly how we kind of lay out our graphics and the way we talk, it is laid out. But obviously the advantage to having a system like this is the ability to not just work like a proprietary system. And if I flip to maybe the IT application, because although we are gearing these switches up and we do pre-configure them for AV, for us at NETGEAR in a networking sense, this is very much a higher networking switch for us. It's what we would call a fully managed layer 3 switch. And we can start when we look at this as the IT application and how we can configure these switches up. Certainly if I look here, these are all M4300 switches. We have the ability to take that traffic and not just look at it in the sense of one proprietary integrated system where everything plugs into that switch and everything plugs out of that switch. Potentially, maybe if I look at the top and we have some of our half size ones that clamp together to form a full use switch, I can have all my encoders on one side, I can have my decoders on the other side. And the way we do stacking, which is the way we interconnect our switches, and it's what we recommend for AV and SDVoE applications, is the ability to take up to 16 10 gig ports, plug those in between switches to create one virtual switch. Now, if I'm looking at a bandwidth sake, just in one direction, I'm looking at 160 gigs worth of bandwidth over that stacking port. And in terms of directions, I can do that both directions at the same time, because switching works on what we call full duplex, which means I can send and receive at the same time. So now I have the ability, if we just say we're basing it on 6 to 8 gig streams, I can send 16 of those in any direction at any time between those. And if I start to think about copper and fiber, again, I can do those at up to 100 meters over copper between the different switches, and I can do that again over fiber. When we look at our bigger switch, which is the 96X, this is the one that integrates 40 gig ports. So again, just on 140 gig interconnect between different switches, I can look at sending 4. Again, I can take that and I can expand on that. And we can look at anywhere up to 240 gig connections to send those streams. And we always base the bandwidth, and the concern for us from a networking perspective is always the switch to switch bandwidth. So when I have to expand out of one switch and I have to look at multiples, and then we have to look at it at a point and say, do you know what, I only ever want to send from this source to this endpoint. And that endpoint could be based on another switch somewhere else. And from that perspective, then we only ever have to account for sending from A to B. And we have to say, well, between that link, I need to make sure there's a minimum of, say, 10 gig for one stream, or 20 gig, or 30 gig, or 40 gig. Then the other perspective is to say, and this has happened, and we've worked with ZeeVee in the past, where they've come along and said, actually, we have 20 plus 4K streams, but we know what that adds up to in bandwidth, but we also want the ability to switch from any encoder to any decoder. And there are multiple switches around the infrastructure that we have to account for sending those. And so we always have to look at that and say, okay, our job now is to work out how much bandwidth we need, and then to work out, if I needed 24 streams, I need multiple 40 gig ports as interconnects between those. And that's our job in terms of how we configure that. So there are a few more questions. We've got a really good question again from Justin, and another question from Kenneth. I'm actually going to just run through this stuff because these are some kind of in-depth questions. I'm going to tackle those in a few moments when we get to our Q&A section. So don't worry, I am going to come back to those questions. Just going to quickly run you through some of the needs and speeds. Now, there are 10 gig models within this range. So the main one there is the 96X at the bottom. There are half-size SKUs. We have ones that are copper, half and half copper and fiber. There are 10 gig modules, PoE modules. But not only that, there are also 1 gig modules. So if you are looking at 1 gig, again, you do have the ability, and all our 1 gig switches do come with 10 gig uplinks. So they still interconnect back at 10 gig to carry that bandwidth. And they have a minimum of 4, 2 in copper and 2 in fiber at 10 gig. There are PoE and PoE plus versions. We have things like multiple power supplies, not just for redundancy, but for also increased PoE budgets. So you can provide up to 30 watts on all of the ports within that switch itself. Now, all of this will be available. I'm not going to run you through every spec on there, but we will make all of these slides and information available to everyone that registered this webinar, and we'll send out details for you to download all of this. And this is the one we're really concentrating on today, and the daddy, if you will, within this family. It is a family of switches. They do all interoperate together. This is the 96X. So again, it's 12 slots. It is a modular switch. You can buy it as an empty chassis. It is zero touch, as are all of the products within the M4300 range. You've got the lifetime warranty. And it's just to note, it is a true lifetime. So there aren't any kind of little stars that say this is for the lifetime we make the product. It is absolute protection for the lifetime that you own the product, not for the lifetime that we make the product. Next business day replacement and online support included, and the ability for a very small marginal cost to upgrade to 24/7 telephone support if you need. Now, looking at that multiple bandwidth, this is kind of what we want to touch on, going back to what Justin said. So when you do need to send multiple streams in multiple places, and you want to take advantage of the fact that now you are on an IP network and you can send that data, this is actually based, I believe, on a ZeeVee installation, Rob.
It is, yeah.
It was achieved. So this is sending 6 times 40 gig port interconnects between 3 different switches, and the ability to switch any of those 4K displays from any source to any endpoint within that network. You're looking at 240 gig bi-directional all the way around within this network. So it's an incredibly high bandwidth, high performing network there. So that's just some of what, and obviously this scales as well. It doesn't have to be in a 3-prong approach. We do what we call spine and leaf stacking and interconnect. So if I just come back to here, you can see, just looking at what we do there, if you look at the bottom right hand diagram, we have the ability to connect up in multiple different ways, as connecting everything up from our spine switches, which we would refer to as our big 10 gig switches, and then have leaf switches hanging off those. So you can achieve big networks and big networks at scale.
And I think one thing that NETGEAR and ZeeVee are very keen on is to, in the early stages, to help integrators and end users with the design of their network, so that it will do everything that they need it to do for their AV. So if it looks a bit complicated at times, that's fine. Throw what the requirements are to us, and we'll work something out for you and guide you through it.
Cool. So we'll move on, and that kind of brings us to an overall end to our presentation today. We're going to come back and have a look at some of the questions. So I know, Justin, you came along and said, when do you think we will have SDVoE ports integrated on devices, removing external encoders and decoders? So I can tell you that already there is a device out there with that, but I'm gonna slope my shoulders and pass this off to maybe Rob. This may be a better question for you to answer. When do you think we'll start to see that happen?
Well, it's already happening. So, of the founding members of SDVoE, so obviously ZeeVee was one of them. There's Sony on there, and there's Christie. So I believe Christie are doing something with their projectors as a first off. They may already be shipping that. I'm not intimately, I don't have the intimate details of all of that and where they are, but Sony as well. And I think that going forward, as the momentum, and we're seeing a huge amount of momentum behind SDVoE. So every week we get more and more inquiries from end users and consultants. And the beauty of SDVoE really is that it's becoming a standard, and so many vendors and companies adopting this standard, that it's inevitable that the display manufacturers and even the source devices are going to start having SDVoE fitted in. Something that I can talk about, even with the NETGEAR switches, there's something that we're looking at on the NETGEAR switches, where the modular switch there, where you can have the 8 ports in. There is some work being done so that there will be an SDVoE encoder or decoder port built into some of those. That's a little way off. Maybe something we can talk about at ISC.
Awesome. So hopefully that answers your question. I think, Justin, really the point is that inevitably it will happen, and hopefully, and we certainly believe at NETGEAR ZeeVee and everyone working with the SDVoE, and that's a lot of big manufacturers believe that this really is the future of how AV is going to work. So inevitably we're going to see more and more of that.
Yeah.
We've got a question from Kenneth, who says, many customers do not want to have potentially hackable audio video products on their network, as I'm informed, AV products do not always meet the highest standards of network security, and this is probably why parallel networks are being used. Oh, it's a really good question. I mean, certainly security is very much on the forefront of everything. The knock-on effect of us interoperating everything and everything becoming IP based, and IoT and Hive, heat your home, and everything that goes with it being interoperating, is the fact that we introduce the risk of us being hacked. And I think that is a risk not just for the AV world, but certainly for everything. I mean, one of the hottest things we see is baby cams being hacked. So I certainly think that's something that's really hot on the press. I mean, hopefully we will certainly work with all manufacturers out there to kind of say your security is up to touch. NETGEAR itself has just introduced a security product, which is our BR500 firewall. So certainly we would encourage that. The fact is, some people do and will always want to keep that traffic separate. That doesn't restrict you from using an IP network. Again, you still get the advantage if you do want to keep that separate, and you do want to keep that as a closed network. Potentially, maybe you don't even want to have the internet connected. You can still gain the advantages that you would have with using an IP network, the ability to send that over huge distances, the ability to even reuse existing infrastructure. If I was to walk into your office, I would imagine it would be very rare for me to find an office that didn't already have a patch panel, didn't already have integrated either Cat5, Cat5e, Cat6, or so on cable, all wired around that building. Now, because I have that already, I can essentially repatch as I like. So I can remove ports on floors, on walls, and I can repatch those out of one IP network, and I can repatch that into an AV IP network. So I can still take advantage of the fact that I've got that infrastructure, and I can still use IP to place my equipment in the same place. I can still take advantage of sending those signals over long distances, things like the resiliency and the redundancy. Now, obviously, that's one side, and I can't really comment too much on the manufacturers themselves, but I would hope that the security is in place. And I think we'll only ever see improved security. NETGEAR ourselves are certainly what I would call a responsible manufacturer when it comes to security. We would participate in what we call the bug bounty programs. So we encourage people to find flaws, holes within our products so that we can go and fix those. I mean, inevitably, these things are a part and parcel of working in IP and within networking and within this world, that these things do happen. They happen with all manufacturers, and all responsible manufacturers out there are part of these bug bounty programs. And if you find bugs, and if you find them, we'll work with you, and we will even reward you with incentives, with cash, with money, with prizes for that, and for helping us to secure our products better. So
yeah, so regarding SDVoE products, Kenneth, what I would say is all of the video is encrypted, so it's AES-128 encryption. So even if someone was able to get that video off the network, what are they going to do with it? They wouldn't be able to view it. But I'm not a security or network expert, but if you go to the ZeeVee website, there is a downloadable white paper which covers just your question in quite some detail. So network security considerations. So just go to zeevee.com and you'll find that paper there.
Awesome. Well, let's see if there's any more questions. I think we did just have actually a couple in the Q&A. So let's just have a look. So we've got a couple of questions from Chris. One of the questions Chris asked was, assuming it's copper, does this need to be Cat6a? So depending on what you're doing, and the distance you're running, you want to look at Cat6a for 100 meters of copper cable, or Cat7 to ensure you can do 10 gig over 100 meters. Chris also asked, would it still work at low res over Cat5? And the answer is yes. So you can do low res over Cat5. It's really when we're looking at 10 gig that you're looking at using Cat6a, Cat6 and above. And what I'm going to do, I am going to endeavor to respond and send out a follow-up message and email and conversations with everyone that joined this. And certainly we are a resource for things like this at NETGEAR. So do use us, and I will send out some information. We'll send out all the slides that came with it. We'll also send out things like how much bandwidth and data you can send over certain distances on certain cables because there is even the ability to send things like 10 gig at very short distances over existing Cat5e infrastructure. So up to 30 or so meters. So even if you are looking at Cat5e, potentially you still have the ability to use 10 gig and SDVoE products over short distances. So we'll send, and I'll endeavor to send that out post this webinar. Mike Hughes also says, given the zero touch nature, is STP enabled by default? Yes, we do have STP enabled by default. So that is spanning tree protocol, which helps prevent storms caused by network loops. We support on the M4300s standard spanning tree, rapid spanning tree, multiple spanning tree, and we even support Cisco proprietary spanning tree. So there are multiple versions on there. You can log onto the switches, and if you do want to take it off, you can remove it. Potentially you don't want it enabled on there. Potentially you want edge ports or fast ports enabled. And NETGEAR does a really good job of creating guides, and we have a whole knowledge base site that you can go to, and you can search things like this, and it gets really simple. We don't just let NETGEAR try and explain, this is how you configure X, Y, and Z. This is how you configure spanning tree. If you go to the NETGEAR website, or if you go to Google and type NETGEAR, what is spanning tree? It will come with a guide on what is spanning tree. You will then find a link that says, this is how you configure spanning tree on X switch, on Y switch. And then you can go away and look at not just how you configure it, but potentially what is that technology, be it VLANs, be it spanning tree, or be it whatever we may do in the IP world. So they do take advantage of that. We do a lot of great work on that side of things at NETGEAR. Chris also says, which one of you guys have jobs going? I love AV over IP tech.
Brilliant.
Thank you, Chris. We'll keep posted. You never know. Check the job boards. This is certainly an industry that we are kind of at the infancy in. Certainly the way we see it at NETGEAR, it's only ever going to get bigger. I think Rob, probably you'd agree with that. So hopefully this is an industry where more jobs are going to be created as we see people transition over to this world and the AV and IP world of video. Well, we've got another question there from Ian Dunk Collins. How about Cisco Meraki? How about them, Ian? They are Cisco Meraki. I'm not sure what you're asking there, Ian.
Yeah. Yes. So, I mean, as a vendor, as I said, we've been involved in so many projects with not just NETGEAR, but with just about every switch manufacturer, and of course with Cisco. What I would say is, if you're going with some of these switches like from Cisco, it's an awful lot complex. It's very, very complex to set up. We've even been in situations where Cisco themselves have struggled to set up a switch for AV over IP for clients, and our engineers have had to get involved with the command line stuff. So of course it can be done. We'll always support it, but I've got to say, for simplicity and ease of use and almost zero touch, NETGEAR is the way to go, particularly if you're talking about parallel networks.
Well, we've got another question from Andrew, just RE spanning tree and the stack diagram. I assume all 40 gig ports are live as a stack and not second, third due to spanning tree. Absolutely. So once we flip a port, and when we do look at operating these systems and you're looking at multiple switches and you are looking at stacking, this is the part where we do have to flip into configuration. Again, we have a white paper written for this, and for SDVoE that documents how to do it. It's a really simple step, as much as logging on and defining a port as a stack port. So there is a really simple guide that demonstrates how to do this. And when you do that, you remove it as a networking port, and it changes from that into a stack port, which means things like spanning tree are completely irrelevant to those ports. So if I was to set all these ports, as you see here on the diagram, as stack ports, spanning tree has no part to play in that, and they will not be considered network loops. We have some really intelligent hashing algorithms on how we send that data over those stack ports. And when we look at having to do that, you can look at things like LACP and link aggregation, but we recommend using stack ports because we believe we have a better hashing in terms of sending video and audio over links when we use stacking. So yeah, spanning tree isn't really a consideration.
So we've got a good question from Ian now, who says, can you track a device address to follow mobile around a building? So absolutely. So with the ZeeVee management platform, we detect encoders and decoders by their MAC address, which isn't a particularly friendly thing, but within the management platform, you can rename that device. So you might want to rename that device to whatever, video wall, some meeting room video wall. Now, if that video wall was on a mobile device on a set of wheels and you wanted to move that to somewhere else in the facility and you plugged it in the network, so long as that network was part of the AV over IP network where you plugged it in, we'd automatically find that. And then it would just be, and you can switch to it without making any changes at all to your configuration or your control system if you have a third-party control system to do the switching. And this is a big advantage. A lot of universities love this in the training collaboration areas where they've got a number of sources and screens, and that space will not ideally want to be fixed. They want to change it according to the event, according to the training that they want to carry out. So that, yes, they will want to move around sources and displays, so together with their encoders and decoders into different network points, and they will just be found. So super, super easy. That's the way to do it.
So I've got another question here on stacking. Does stacking require a full loop between all switches in the stack, i.e. A to B, B to C, and C to A? Good question. So that would be daisy chain and a 1-over, which the answer is to no. So you can operate in a loop if you want. You could operate in a daisy chain, which is not really recommended, but you can also do what we recommend, which is spine and leaf stacking. So if I was to have a 10 gig spine or even a 40 gig spine, I can then plug in all my leaf switches, and I can even create completely interconnected topologies. And that's one of the great advantages of the way we do stacking on these switches, that you really can connect every switch to every switch if you want. You can go with spine and leaf. You can go with a daisy chain or once over or a loop. So you really have flexibility to stack these switches any which way you want. And I'll, again, in the information that I send over, post this, we'll include some guides on how we do that and all the different things that go with it. We do have a question actually that I did just miss there about, where has it gone? From Justin. Can you please tell me the difference between the IGMP Courier version 2 and version 3? Oh, good question. So IGMP 3 was introduced for source-specific multicast. So there are some minute differences, and again, that's it can go quite in depth. So what I'm going to do is I have some documentation on differences between version 1, version 2, and version 3. And we are making a note, and we do record all these questions. So what I'll probably do, in fact, is I'll record all of these questions, and we'll send up in the follow-up answers to all these questions, and we will mail them out to everyone that's on the webinar, so that everyone can have a written question and answer sheet just to everything we've discussed today. So I'll send that post to you, Justin. So we are running up just over our time limit actually now, I believe. So we're hitting 11:30. So just see if there's any more questions. Let's see, we've got another question from Ian. What is the maximum number of devices you could follow? So you wanted to give all the students of a uni a phone and do access control to a room, to level of a room. Can that be done? I presume we're talking about the networking side of things here now, Ian. So certainly with our switches, if you're looking at a per switch, we do support full ACL support. So we can do some pretty cool stuff with ACLs, all the way from anything up to layer 4. So potentially we could do what you want to do there. It very much dependent. And again, when we send this out, do feel free to reach out to us, and we will include all our contact details. So if you are looking for networking support or AV support, We will include our details. Please don't hesitate to reach out to us and have conversations with us, or either email or on telephone, and follow-ups to discuss anything you want to look at in terms of networking and AV.
Okay, I think we've run out of time really now, Kieran. So
I think we have.
I mean, so if you do have, as Kieran said, if you do have any specific questions, just contact Kieran and myself, and we'll get you the detailed answers back to those.
Awesome. Well, look, as per usual, thank you guys for joining us. Thank you, Rob, for joining us. I think it's been a really good experience to leverage your expertise and knowledge within the world of AV. So thank you very much. And we'll be going again. So what's coming next, guys? Just to note quickly, we will be live again on the 13th of December, when NETGEAR will be doing a webinar and an overview of our NETGEAR Insight Cloud managed platform. So that's our platform that can manage switching, wireless, storage, and security from anywhere, anytime, any place, and any device. So that's both Windows, iOS, Android management, as well as VPN access into that network for any device, anywhere. So do join us for that. We'll be giving you an overview of the solution and some live demos on the product itself. We'll follow up with everyone that joined and everyone that registered for the webinar, and we'll send out all the information today. And any questions you have, don't hesitate to reach out. Otherwise, thank you for taking the time out to join us today. We do really appreciate it, and we will speak to you very soon.
Thank you, everyone. Thank you, Kieran.
Cheers all.